Ladies and gentlemen, thank you very much for giving me a voice. I would today talk about sequential dark fermentation combined with microbial electrolysis cells. This is based on the newest article from Bioresource Technology in volume 374 of Professor Eric Trabley from Montreal University, and the topic would be the mesophilic bacteria of two kinds, microelectrolytic cells and dark fermentation. The stream is coming of food waste is coming to dark fermentation reactor, and then these organic acids are in the other reactor of microbial electrolysis cell, split it to hydrogen again. So we have set up to optimize hydrogen production from the food waste. And the pH was 5.5. And then, in case of dark fermentation, resulting 72 hydrogen per gram of chemical oxidant density. And then the butyric acid, mostly, and give the to the reactor of pH of 7, and then get higher hydrogen because they gain from microbial electrolysis 733 milliliters per gram of waste. The removal of acid was 84 to 95%. The output was much higher, and the energy was recovered. So everything was suitable and very efficient. There is reason because we need to replace our conventional methods into the renewable energy. We need to replace oil and gas into something from biomass. And this is the solution that can make it. The combination of dark fermentation microbial electrolysis cell use food waste as substrate, and then the inoculum was taken for France because Eric Trabley is from France University. And these bacteria were chosen, and inoculum was activated and freeze dry. Instead of mostly heat shock, they just decided to make inoculum into to freezing first, and then for minus 80 degrees bacteria was coming then again to heat shock. So first freeze shock and then heat shock after 30-50 minutes. So double shock. So we have two kinds in one after another. Therefore we get quite hydrogen production. It results that then, in case of aerobic of microbic, they wasn't, because all was from sludge. So it was typical like a coction fermentation. However, it's fermented like this was in Chinese one from university. But this is not mentioned because this is for another topic. And this, by combining these two methods, they obtain very high efficient setup. And I think because we don't need extra energy in case of butyric acid, it's similar to to ammonia. This shows that we can obtain some waste and some substrate for microbial which are not water. Unfortunately, water is too high and we need to extra energy. In case of organic acid, we don't need any charge, so we can use as source of hydrogen independent and green. Thank you very much for listening to me.